Now let's go ahead and apply our solution outline to the second equation. So we have that ln x plus 1 equals 1 plus ln x minus 1. 1 plus ln x plus 1. Oh, I think I misquoted the problem statement. The plus 1 is on the right-hand side. There we go. So remember the outline. We're trying to get the logarithm, in this case it's going to be the natural logarithm, of some single thing equals some number. And in order to do that, I think I'll go ahead and subtract this term from both sides and use properties of logarithms. So I can rewrite this as ln x plus 1 minus ln of x minus 1 equals 1. And now I can use the properties of logarithms to get ln of x plus 1 over x minus 1 equals 1. Now I have a form of ln of something, logarithm of something equals a number, and I can apply the definition of the logarithm. So ln of something equals 1 means we'll move the base over to the right-hand side. This will become the exponent. The base, of course, is e, so we get x plus 1 over x minus 1 equals e to the first power, or in other words, just e. Now the equation that results here, x plus 1 over x minus 1 equals e, that's called a rational equation. Probably the easiest way to solve it is to multiply both sides by the denominator first, and when you do that, you'll get a resulting linear equation. So multiplying by x minus 1 on both sides, that clears out the denominator on the left-hand side, and what results is x plus 1 equals e times x minus 1. And I can go ahead and distribute this e, and I get x plus 1 equals ex minus e. Don't let the e complicate or make things too complicated for you. E is just a number, so we're going to approach this problem as if e is a number, because it is. And the way that we approach linear problems when x is on both sides is we get all the x's on one side, all the non-x's on the other. So I'll go ahead and subtract ex from both sides and subtract 1 from both sides. That will eliminate my plus 1 on the left-hand side, and it'll eliminate the ex on the right-hand side. The resulting equation says x minus ex equals negative e minus 1, and we can factor out an x from the left-hand side, and we get x times 1 minus e equals negative e minus 1. And finally, we'll divide by 1 minus e, and we get that x is equal to negative e minus 1 over 1 minus e. And finally, all that's left to do is to check to make sure that this solution does not make us take logarithms of numbers that are less than or equal to 0. So in order to do that, I will go ahead and use a scientific calculator to get a decimal approximation for this. This ends up being about 2.164. And if I look back at the original equation, if I put x equals 2.164 here, then I will get a positive number when I add 1 to it. And when I do 2.164 minus 1, again, I get a positive number. So I'm taking logarithms of positive numbers everywhere, and so I will go ahead and claim this to be the only solution. Again, if this were negative, then we would not include it as a solution, because negative 2.164, if we put that, for example, over on the left-hand side, negative 2.16 plus 1 would still be negative. Okay, so now that we've done a couple of these problems, I just want to make a brief remark on why we have to worry about introducing these extraneous solutions. Now, hopefully you'll agree with me that one important part of our solution methods or solution method, is using the logarithm properties. The logarithm property says that log of two things multiplying one another is the sum of the logarithms. And of course, there's a division and a power property as well. I'm just going to look at the multiplication property for now. The reason why we have to double check our answers, because this actually isn't true for every a and b. It's true when both a and b are positive. Otherwise, it won't be true because you cannot do log of a number that's less than or equal to 0. So essentially, at the end of each problem, what we're really checking is we're saying, hey, if this is my x value, can I actually apply the logarithm property that I want to be true? If one of these ends up being less than or equal to 0, then you can't apply the logarithm property. And so we discard that solution.